Hi guys, welcome to Beginner-Techies. In this video, I'm going to discuss about another problem of sliding window technique. In the last couple of videos, I have already discussed few problems and I have solved those problems with the help of sliding window technique and also discuss about the sliding window technique. If there is a problem, so how can we actually identify whether this problem is applicable to solve with the help of sliding window technique? So if you don't have understanding about the sliding window technique, first I would highly recommend you to go through that video. I will share the link of that video into the description box. Okay. So let's see this problem. How can we solve this problem with the help of sliding window technique? This is the most frequently asked question in coding interviews. So let's go through the problem statement first. So the problem is longest substring with at least k repeating character. Longest substring with at least k repeating character. Given a string s and an integer k, return the length of the longest substring of s such that the frequency of each character in this substring is greater than or equal. Let's see this example so that we can get better understanding. Here input is given string and k is equal to 3, right? So we have to find out the max length of substring, right? And in that substring, each character should be the frequency of each character should be greater or equal to k. This is the conditions we have to check into the substring. So if you see this, a repeated 3 times and b repeated 2 times. So if we just consider this substring a and then b, so b is repeated 2 times only, which is less than k, right? So the max length should be the substring will be AAA and max length will be the size of this substring. So this will be the output. If you see this example, the string s is given, k is equal to 2. Here character is a b, b, c. So if we see the substrings, first k is 2, so we will like the size of substring will be at least k size, right? So let's see if the substring is ab. So in this case, a is less than k, b is less than k. So this will not be considered. Again a, so a is greater equal to k. This is fine. Again b. So if we see this substring ab, in this substring, a is repeated 2 times, b is repeated 2 times. Okay. So this will be the considered substring, and the size of this substring is 4. Now we will move forward and check again. So here if we consider this substring ab, so this substring is also valid substring, right? Because in this substring a is 2 times and b is 3 times, which is greater or equal to k. And then move forward again, we will there might be some more character with a and b, but here it is c only. So c is repeated 1 time, which is less than k. So till this position b, this will be the valid substring. Okay, and this is the max substring, max length of substring, right? This size will be 5. So this will be the output. So draw example over here so that we will get understanding. A, B, k is equal to 3, right? This is the example given, example 1, right? So we have to find out the max length of substring, and in that substring every character, frequency of every character should be greater or equal to k. Here if you see this is the substring a, which is valid, right? And length of this substring is 3. If we go with this, this is not a valid, because here frequency of b character is less than k, right? This will not be a valid. So this is the final output will be, so the final output will be 3 only. So how can we approach this? How can we solve this problem? If you are talking about sliding window technique, so yeah, this problem can be solved with the help of sliding window technique, because in this problem we are talking about string, right? In this problem we are talking about substring, and window size we have to make, because two types of windows, size, fixed and variable, right? I have already discussed these things in the previous videos. I will share the link in the description. Okay. So this problem, like this condition is like this condition are satisfied with this problem, so we can go ahead with sliding window technique. Sliding window technique. Now the problem is, like, how can we approach, how can we create a window, how can we expand a window, how can we shrink a window? If we are thinking, if we are talking about sliding window technique, then two things we should be here: shrink the window at certain point of time, expand the window, right? Expand the window. These two things we have to consider while applying sliding window technique. Okay, right. Right, so let's see how can we apply sliding window technique over here. We have this example, k is equal to 3, right? And for sliding window technique, I generally use two variables, I is equal to 0, j is equal to 0. Window size will be what? Window size will be j minus, right? So this is the right pointer, this is the left pointer. Okay, so I'll move j. So at j is equal to 0, we have a, and frequency of a is 1. At j is equal to 1, we have a again, frequency of a is, sorry, frequency of a is 2. J is equal to 2, we have another a, frequency of a is 3, right? So we have this, right? We got this substring, right? Because this is greater or equal to k. So at this step we have to calculate the length of window, or substring, you can say substring. Okay, so once we got the substring, once we got the length of substring, so at this step we have to either shrink or expand, right? Shrink or expand. This is what we have to decide at this step. But here we cannot decide, because there might be another is, there might be some other characters further. Okay, so in that case we cannot decide to shrink or expand. If we see j is equal to 3, we have b, and the frequency of b is 1, right, which is less than k. So we cannot calculate substring length, right? So we have to think about the approach. You have to apply sliding window technique, but there will be slight changes. So here the idea is let me consider the same example, or we have another example, right? Let me copy the another example over here. This one, okay, this will be better. Okay. So AB, BC, right? AB, BC, K is equal to 2. Okay, so we have this example, and we have to find out the max length. We cannot apply the approach we have discussed here, right? We have to think about some other approach, but we have to apply sliding window technique. So the idea is, either we calculate unique character, in the substring, sorry, in the string, or we can, or like if we consider any substring, so any substring can have maximum 26 unique character, right? Or else we can consider 26 max unique character. (26 max unique characters, right? Because in alphabet, in the constant, if you see here, so the constant is given. So S consists of only lowercase English letters. So this string will consist only English letters, right? So we have total 26 character in English alphabets. So each substring, if we have a large data set, so in each substring we can have max to max 26 unique characters, right? It should not be more than 26. So either we can calculate the unique number of unique character from the string, or we can simply run through the 26. We can consider the 26 max unique character. So this is what we have to do. Let's suppose I'm just considering this approach. Okay, we have max unique character is how much? A, B, and C. Total 3 characters. A, B. So if we find out if we found any valid substring from this string, any valid substring, so that substring should have maximum these 3 character A, B, C, right? So that we have to check right. Right, so let's see, like here total, right? So max unique characters are, max unique character is equal to, here A is, B, and C. These are the 3 unique character in this string. So if we get any valid substring, in that substring we will have only these 3 characters. So if any string is given, we have to find out the unique character. So once we get the unique character, then we will start from the 1, like from the unique character 1 till the size of that unique character. So here we will start from max unique char is equal to 1 till the size of what, this one. Okay, so right now the size is 3, so we can consider 3. Okay, so here we can remove this, so size 3, right? So if max unique char is 1, if initially we are considering this, so in this case in the sliding window, there will be only one unique character. If it is 2, then there will be 2 unique character. If it is 3, if it is 2, then 2 unique character in the window. If it is 3, then how much? 3 unique character, right? 3 unique in the window size. So this is what we have to think about, right? So this way, this approach we have to apply. So let me draw one table over here so that we will get better understanding about this. Okay. Here the character, here the unique char, and here frequency of each character, and here max length. Okay, so if, yeah, so I have to declare 2 variables, I is equal to 0, j is equal to 0, as I declare here already, right? Okay, so I is equal to 0, j is equal to 0. If j is equal to 0, j is the right pointer. First I will increase the j. Okay, so j is equal to 0, character is a. Okay, let me ab bc, it ab bc, this is our string. Yeah, so j is equal to 0, character is a, unique char is 1. Here we have a only, right? So a is a unique character, frequency 1, max length we cannot calculate because we can only calculate once once the substring is greater equal to 3, right? Greater equal to k is 3. Now j is equal to 1 and character is b. In this case, this is another unique character, so unique character count becomes 2, right? Which is greater than what? Max unique char. Initially we have we are doing max unique. Okay, let me add one more column here. Sorry. Max unique char. Okay, this is 1, right? This is 1. We are iterating on this, right? Max unique char is 1. So in this case, unique char is 2 and max unique char is 1. In the sliding window, there will be maximum 1 unique char if max unique char is 1. So in this case, the condition is getting failed, right? So if unique char is greater than max unique char, let me add the condition here. If unique char is greater than max unique char, in this case we will shrink the window. We will shrink the window. Remove ith element. Okay, right. So in this case we have to remove the ith element. So I is equal to 0, j is equal to 1. Now we have to remove ith element. So ith element at 0 position we have this a, right? This should be removed. So I'm just removing this to avoid any kind of confusion. And this b, yeah, right. So I is equal to 1, j is equal to 1. Okay, so now j is equal to 1, j will become 2. So at 2 we have a, right? So again we have 2 unique characters, right? But max unique character is 1. Max unique character is 1, but again we have 2 unique characters which is greater than 1, right? Which is greater than 1. So again we will shrink the window. So I is equal to 1 because unique character is greater than max unique character. So I will become 2 and j is equal to 3. So in this case this row will also be removed. Okay, now j is equal to 3. In this case another character is b. Again we have another unique character. We should have only one unique character, right, as per this condition. But this is second character, right? Second unique character. So again the condition is fail. So in this case we have to shrink. In this case we have to remove this ith element. Okay, we have to remove ith element and I will become 3 and j will become 4. Again we will check 4 here for b. So here it is b. Okay, so this is unique character, right? This is unique character. So here it should be 1, this should be 1. So it is equal to unique character. This condition is satisfied, but frequency is what? Frequency is 2. B is occurred 2 times, right? Which is less than k. K is 3. K is 3, right? So again we cannot calculate the max length because the condition is not satisfied. Now j is equal to 5. In this case there is another character c. So if there is c, then we have 2 unique character, right, in the window. This is second unique character which is greater than max unique char. We should have only one unique char in this window. Let me add this color. In this window. So here in this case condition is fail. We have to shrink again, right? We have to shrink again and I will become what? I will become 4 and 5. So we have to remove these two characters. Okay, so this way we have to remove to shrink the window. So for max unique char 1 we did not get any valid substring, right? We did not get any valid substring. So now we need to check further for max unique char 2. Right now we have checked only 1, right? Now we have to check for 2. Now this should 2. So in this case j is equal to this will iterate again. J will be 0. This is a unique char 1, frequency 1, max length we cannot calculate. Now again j is equal to 1. Next character b. Yeah, so unique char is 2. Here it is also 2. Condition is satisfied. Frequency is this is the base frequency, it is 1, which is not condition is not satisfied. It should be k greater equal to 3, right. So we cannot calculate max length. Again j is equal to, sorry, j is equal to 2. Again we have a, yeah, so unique character is 2, right? A 2 times and b 1 times. There are 2 unique characters only in this window, right? So unique character is 2. Frequency is what? 2. For a it is 2, right? For a it is 2. For b it is 1, right? So again it is, yeah, it is k is equal to 3. Here it is less than k, so the condition is not satisfied. J is equal to 3. Now what is the character? B. So here if you see, again we got the b. So again in this if we see in this window, we have a total 2 unique characters, right? Still we have 2 unique characters. Condition is satisfied. We don't need to give any shrink, we just need to expand, okay, right? So frequency is what? 2, right? We have 2 A's, 2 B's, right, in this window, but still the condition is not satisfied. Okay, sorry, k is 3, sorry, k is 2 in this case. Sorry. K is not 3, it should 2. I did mistake. K is, right. So the condition is satisfied. So we have to calculate this, what, this window, this length. So the length of this window size is what? 4, right? So till now we got the AB means 4, right? Now we check further. J is equal to 4, right? So again we have what? B, right? Again we have only 2 unique characters, right? So the condition is still satisfied with max unique char, right? So frequency is what? B's frequency is 3, B is 3, A is what? 2, right? So still this condition is satisfied, right? Because B is greater equal to 3, B is greater equal to K, and A is greater equal to K, right? Both the condition are satisfied. So in this case we will consider this, because we have to find out the max length. So max length will be 5 in this case, okay, right? Now we will check for 5. This is C, and here C is different character. If we see in this window, so we will have total 3 unique character, right? Total 3 unique character. So we cannot right. So the condition is getting failed, right? Here it is 2, and here it is 3. Unique char is 3, max unique char is 2. So in this case we will shrink the window. We have to remove these 3, we have to remove till B, right? So we have to shrink, okay. So I'm just removing this thing for understanding purpose, okay. So we have to remove all the calculation. So again we will check for max unique char 3. In this case j is equal to 0, char is A, and unique char is what? A, sorry, 1. Similar ways we cannot calculate length, right? So same way if we see, so we cannot get valid substring with this with the 3 unique characters, right? So our output will be what? Our output will be what we have calculated with max unique character is equal to 2. So our valid substring length will be 5 in this case, okay. So this way we have to build our logic, right? So let us write the code into the cheat code so that we will get understanding. Okay, so let's write the code here. Right. So let's write the code into the cheat code so that we will get understanding. Okay, so let's write the code here. Okay, so let's write the code into the cheat code so that we will get understanding. Okay, so let's write the code here. Okay, so let's write the code into the cheat code so that we will get understanding. Okay, so let's write the code here. So first I'll calculate the length of substring. Okay, right. And now I will create one set to calculate the unique characters. Okay, let me name it as max unique char is equal to new hash set. Okay, so we'll write one for loop here. Int I is equal to 0, I less than what, s dot length, right, and I plus plus. Okay, so here in the max unique char I'll add, sorry, it should be character. I'll add is dot caret what, I. Okay, right. Okay, so now I'm just yeah, so we have to write one outer loop. Unique char is equal to 1 and I less than max unique char, right, dot size I plus plus. And here I will create these variables. I is equal to 0, which will be a left pointer. Int j is equal to 0 will be right pointer. Okay, now, right, so here we'll start from j less than n, right, till length of string. Now we have to check, what we have to check, if unique char, if unique char we have to check two things, right? The first thing is frequency of each character should be greater equal to k. This is one thing we have to check. And the another thing is we have to check is frequency of each character greater equal to k, and it should not be so unique char count less than unique char, less equal to unique char. Okay, so these two things we have to consider, right? So for that I will create one variable here, int, the same variable, int unique char count is equal to 0, and we have this, right. So we have to maintain one map here. It should be character and integer. So count map, char map, char map, map. Okay, this one we have to create, right. Have to add the condition. So unique char count should be less equal to what, unique char, right, unique char, this should be less than unique char. And here we have to add the character into the map. S dot j char map get a default s dot char at j If it is not there, then it will be 0, otherwise it will. Okay, so now we have to check number dot s dot char at j if it is equal to 1. If it is 1, if then we have to, if this, like if this is unique character, then we have to increment the unique char count, right? Otherwise we have to so this is one condition we have to add, and the another condition is we have to check the frequency. First we have to check the like unique characters, and the second condition is we have to check the frequency, right? So in the count map we need to check s dot char at what j is equal to k. So in this case we have to increment the what, we have to maintain one more variable here, count k time, okay, is equal to, okay, so this should be count k time, right? And here we have to increment j plus plus, or else we have to shrink if this condition is not satisfied. Like if unique char count is greater equal to unique char, max unique char, so in that case we have to shrink the window. So what we will do, so in the char map we will simply put what, this is s dot char at, so we have to remove the ith element, and char map dot get s dot char at I minus 1, right? Right, so we have to remove, if it is if char map dot get s dot char at I equal to 0, then in this case we have to decrease the unique char count, we have to remove the unique char count, and this should be decreased. And if char map dot get s dot char at s dot char at I equal to k minus 1, if it is less than frequency, then we have to, if it is less than k, so then we have to reduce minus, and here we have to increment, right? And here we will check if unique char count, if unique char count is equal to unique chars, we have unique char, and and then count k time equal to unique char. In this case we have to find out the max length. So here we have to define one more variable, int max length is equal to 0. Okay, so here we will mat.max. So mat.max right minus mat.max, we have to find out the max length. This should be max length and this should be j minus I. This is the window, and from here we can simply return length, right? So let me run this problem. Cannot find symbol. Okay, sorry, this should be unique, right? Should measure. Okay, so this bracket should be closed here. Is this? Now run it again. So these two test cases are passed. Let me submit this. So out of 37, 31 test cases are passed. 6 test cases are getting failed. What is the issue with this? AA. Okay, so this one is failing. Okay. Okay, so this should be here equal, right? Equal to right. So all the test cases are passed and now the solution is working fine. So let's do one quick change here. In the submission we can see total 37 ms it took. Let me just do one quick change here. Let me just I'm just making it 26 because in the English alphabet we have total 26 character. So instead of calculating these things, we can ignore this part and um, yeah, so we can simply use 26 and let's see what are the impact. So this is also submit, but it took 45 ms, right? So every time we are iterating 26 times, right? So if we see, if we are just considering this solution, like if we are just calculating the number of number of if we get the number of unique characters, so we just need to iterate till the size of unique character, right? We don't need to iterate every 26 times, right? So we can just improve this one if we simply use this max unique, we can calculate the unique number of unique characters and we can iterate till the size of unique character. So in this case the the complexity of this overall solution will be, like if we are considering 26, then yeah, so the complexity will be 26 into n, right? Complexity will be 26 into n. But if we are considering the above solution, then it will be complexity will be what? Complexity will be max unique, whatever the size, into n. So let's suppose in this case we have total 3 unique characters, then the complexity would be 3 into n. But if we are going through this 26, like if you are checking all the if you are considering 26 unique characters, then in that case the complexity will be 26. So this is the difference if you are going with the, if you are calculating the unique characters, and if you are going with, if you are considering 26 unique characters, if you are considering all the alphabet in a single substring, then yeah, so these are the little differences in the performance. So see you in the next video. Thank you. Bye bye.